This lecture discusses the solar atmosphere. The learning goal is to be able to describe the sun's atmosphere. The solar atmosphere consists of three layers: the photosphere, the chromosphere, and the corona. The photosphere surrounds the convective zone. The photosphere is regarded as the surface of the sun. In the atmosphere, the density drops very rapidly with increasing altitude. The solar atmosphere is much less dense than the atmosphere of the Earth. This is figure 1.11 in the book. The temperature and density of the sun's atmosphere change abruptly at the boundary between the chromosphere and the corona. The density of the sun also decreases moving outward from the core. The temperature is not uniform within a layer. The lower layers of the photosphere are hotter than its upper layers. Understanding how the corona is heated is an area of active research today. The photosphere is the narrow layer of the sun where light is emitted into space. It is only about 500 kilometers thick, which is small compared to the sun's radius, about 700,000 kilometers. This photosphere is the surface of the sun. Recall from Chapter 10 that we wouldn't use the word surface to describe a gaseous region. However, astronomers refer to the part of the star that gives off the most radiation that we see as being the surface. This surface is not like that of a solid body and is not the outermost layer of the sun. Figure 11.12 illustrates the photosphere. Look at the image on the right. Notice how the outer edges do not look as bright as the center. This is a real effect, not an illusion, and is called limb darkening. Limb is the term astronomers use to identify the outer edges of the disk of a star or any circular-looking object. Limb darkening is an optical effect seen in stars, including the sun, where the center part of the disk appears brighter than the edge or limb of the image. The figure at the right shows the measured brightness as we look across the disk of the sun. When we look at the center part of the disk of the sun, its temperature, found from the black body continuum, is around 5,800 Kelvin. We cannot see all the way to the center of the sun. We can only see so far down. Astronomers would say we could only see the region where the opacity is high. The depth is only around 400 kilometers. Then the photosphere's opacity becomes too high. When we look at the limb, we can still only see so far down, but it looks darker because we are looking into cooler, higher regions of the atmosphere. As we learned in Chapter 10, if we see the spectral lines of hydrogen, helium, carbon, oxygen, or other element in the light from a distant object, then we know that element is present in that object. Looking at the spectrum image, we see the colors are interpreted by dark bands. They are not all the same size. Some are strong and some are weak. The strength of a line is determined in part by the number of atoms present. From the strength of these lines, the abundances of the elements in the sun and other stars can be determined. The shape of these spectral lines also tells us about the temperature, density, and pressure of the gas. The chromosphere is located above the photosphere. It has a higher average temperature than the photosphere. This is counterintuitive. We would expect the temperature of the sun to continue to decline at distances further from the core. Here, the temperature increases outward away from the sun. This phenomenon is thought to be related to the sun's magnetic field. Because the chromosphere is hot and because it has low density, it gives off an emission line spectrum. Some of these lines are in the visible part of the spectrum, but most are in the ultraviolet. The name chromosphere means the place where color comes from, because the red hydrogen alpha emission line seen in the sun. The corona is a very extended layer of very hot gas. The corona extends from the top of the chromosphere to the solar wind. The temperatures in the corona reach 2 million Kelvin, enabling the corona to emit X-rays. Recall that X-rays are very energetic photons, but the corona is so low density that we only see it with the naked eye during total solar eclipses, as in the photo. Certain points of the corona can extend for several solar radii away from the sun. In technical jargon, the corona represents the non-LTE region of the sun's atmosphere. Simply, what this means is that different ways of measuring temperature will give you different values. The visible light from the corona is due to the motion of electrons because of the low density, can move at very high speeds, which we interpret as a high temperature. In summary, the sun's structure is maintained by hydrostatic equilibrium. Nuclear reactions converting hydrogen to helium are the source of the sun's energy. The sun has multiple layers, each with different densities, temperatures, and pressures.